My dear students, let's discuss one question here. Why the dissociation energy of fluorine molecule is very less than that of chlorine? We all know that the dissociation energy of fluorine molecule is 1.64 electron volt, whereas chlorine is 2.48 electron volt. Both are on the same group, both are halogen, right? So let's discuss what is the reason. The main important reason is we will find it out. First, we will write the electronic configuration and write down the case of fluorine. It is 1s2, 2s2 and 2p5. We all know that fluorine molecule is having very compact structure because of very high nuclear charge and due to the presence of very high penetrating power of S subshell, which is more contracted towards the nucleus, and the P sub level, the P subshell is very small. All these right when we considering when the non-bonded, we all know that this is a nucleus, this is 2s2p5 and this is 1s. Okay, this nuclear charge is more, it will attract the core electron as well as the valence electron more towards itself. So due to the presence of this lone pair and the very compact size, the non-bonded p electrons, these lone pair of electrons will provide an electron repulsion on the bonded electrons of bonded pairs of the p orbital. So as a result of that, there is an electron repulsion is there. This electron repulsion between this lone pair, this non-bonded p orbitals, these are called non-bonded p electrons, and this is called bonded p electron. When a fluorine atom is bonded with another fluorine atom, the incoming through a covalent bond, this electron, the bonded electron experiences a repulsion from the non-bonded p electrons. As a result of that, the bond length, there is the dissociation energy of fluorine atom will decreases. This is the main reason is electron repulsion between bonded p electron and non-bonded p electron. When we consider chlorine, okay, the electronic configuration is 3s2 3p5. Okay, so similarly, there is also a chance of electron repulsion, right? There is also a chance of this bonded p electron and non-bonded p electron, but that is not happening in the case of chlorine. The reason is due to the presence of 3D. This is the speciality of the third period elements. There is a vacant d orbital is there. There is a fluorine atom. There is a vacant d orbital is there, and the lone pair of electrons present in the p subshell. The p subshell of the lone pair of electrons present in the p subshell of one of the chlorine atom is donated to the vacant d orbital. The vacant d sublevel 3d. Okay, the lone pair of electrons present in the p orbital of one chlorine atom is donated to the vacant d orbital. As a result of that, what is forming? A d pi p pi back bonding. Right? D pi p pi back bonding. This is a special case of bonding, a pi bond, where dp pi bond or d pi p pi back bonding or back donation. D pi p pi back donation. All are the alternative names. This back bonding resulted in the strongest bond. This resulted in the strong strength. This will strengthen the chlorine covalent bond. As a result of that, the dissociation energy of chlorine Cl2 chlorine molecule is higher. Let me repeat again. This d pi p pi bond is formed when there is a vacant d orbital is available. That is the first condition. And the atom, when it is formed when an atom is having lone pair of electron which is donated to the vacant d orbital through a back bonding. As a result of this back bonding, which is the strongest pi bond, which will strengthen the existing covalent bond, which will strengthen the existing bond or the covalent bond. This is the fact that chlorine molecule possesses very high dissociation energy than fluorine. And this presence of this 3D vacant 3D subshell is only available for the third period, not available for the second period. That is the reason fluorine is having very less dissociation energy than chlorine. Moreover, the electron-electron repulsion is more prominent in fluorine because there is no vacant space. Only the bonded p electron and the non-bonded p electron will repel. But here, the non-bonded p electron, the lone pair, which is a lone pair, which will donate to the very more spacious, the vacant d orbital through overlap. Okay, this is through back bonding. This is the reason. Okay, thank you.